Kia ora koutou, ko Tiffany taku ingoa, he kairuruku tauwhainga ahau ki Manaki Whenua. Good morning everyone, my name is Tiffany and I am the Events Coordinator at Manaki Whenua Landcare Research. Before I hand over to Hugh, I'm going to run through a couple of technical slides to ensure that your experience with us online today goes as smooth as possible. If you've joined us previously for a webinar session, you can ignore me for the next minute. You will notice you have a control panel at the side of your screen. If at any time this collapses, you can bring it back by simply clicking the orange arrow button. If you are having sound issues and you can see my mouth moving but cannot hear what I'm saying, please grab the PDF in the handout section, and this has instructions to resolve this quickly. The audio panel is where you can control where the sound plays on your computer. Select the drop-down arrow and choose your audio output. During the presentation, you may have questions that you want to be covered in our Q&A session. You can do this via the chat panel throughout our session today. You will notice it is pretty small and it will be hard to read other attendees' questions. Select the pop-out icon on this panel and drag the corner out to make it as big as you want. You can also use this feature if you are having technical issues and ask me any questions. Questions asked by the audience show as anonymous and a green colour in the chat panel. However, please note we will use your name in the Q&A session. If I respond to you regarding a question, this will show as red. Now over to Hugh to introduce you to our 8th session for the Biosecurity Bonanza series.
Kia ora koutou, and thank you, Tiffany. Hello, I'm Hugo Leigh. I've been working in the field of biological control of weeds and in this kind of team for nearly 40 years now. So it's been great to be involved in this online biosecurity bonanza this year, which is quite a change from our previous years. Excuse me. I'm also here to facilitate this webinar and to handle the question and answer session at the end of Paul's talk this morning. So Paul Peterson. So Paul is one of our specialist technicians and has done a huge amount of practical field work on our biological control agents that have been released into New Zealand. Paul is based in Palmerston North and is here to tell us about his latest findings on the Hieracium biocontrol agents. I can remember when the Hieracium biocontrol program started. I think I was quite a young lad back then. It's been going for such a long time, and it's great to see that we're still doing work on this project and then we're still following up on the biocontrol. So Paul, take it away.
Thank you, Hugh. Right, so the title of my talk is Hieracium Biocontrol, and it's a 20-year progress report. So Hieracium Pilosella is often just called Hieracium or mouse ear hawkweed. Excuse me. At least 4 other hawkweed species are in New Zealand, but Pilosella is the most common and most damaging. So it excludes other plants and reduces feed availability and represents a threat to conservation values in the South Island High Country and in the Central North Island. Concern about Hieracium invasion in the 1980s led to the formation of the Hieracium Control Trust in 1993, and biological control agents were sourced and imported. So since 1999, sorry, I've lost my... We've had 5 agents imported into New Zealand. So we have a Gaul wasp, a Gaul midge, 2 hoverflies, one that feeds on Hieracium roots and one that feeds in the crowns, and a plume moth, which is also a crown feeder. However, only the Gaul wasp and the midge have actually established. So since between 1999 and 2006, there were 99 wasp releases and 32% of those established. And there were 136 midge releases and 92% of those established. So this is what a gall looks like. So the Gaul wasp galls stolons, so the vegetative growth that comes off the Hieracium mother plant and forms daughter plants. So the wasp lays eggs in the tip of the stolon, and the eggs hatch, and these wasp larvae emerge and they feed inside the stolon and a gall is formed, and they feed on that material. So it stimulates gall formation. I've noticed quite often in the field you see these stunted or miniature leaves, and they're often associated with galls. And so if you're looking at Hieracium on the ground, you can quite often see galls just because of the leaf formation if you get your eye in. So you can see a few there that I've narrowed. So the gall midge galls the crown, and you see this leaf deformation. So the larvae are inside, the adult lays eggs in the crown, and the larvae burrow into the leaves and feed and form these galls or deformations. You can have several generations per year, but at the end of the season, the mature larvae drop off and pupate in the soil, and they overwinter in the soil. And I forgot to mention the wasps, actually, they overwinter inside the galls, so they're a little bit different in that respect. And this is another shot of gall midge or gall midge damage. Sometimes you actually see some death in the crown, and I've found plants like this in areas where gall midges are quite common, but I couldn't confirm whether or not that was a death due to gall midge damage. So recently we wanted to have another look at how well the wasps and midges have spread and what impacts they've had. So we checked 56 sites. We checked sites in the Central North Island, in Canterbury, Otago, and we had our field trip all lined up from Marlborough, and the day before I was due to fly out, we went into lockdown, so we couldn't go to Marlborough, which is unfortunate. So what I'll do is I'll talk about the North Island and the South Island separately, because we've seen different things happen in the North and the South. So in the North Island, we've had very poor wasp establishment, virtually no spread, and no damage, significant damage. Whereas midges have established it at nearly all sites we've released them at, and they've spread over about 10 square kilometres. So this is an area in the Wairu military training area, where they run training operations, and there's a lot of Hieracium in this area. And you can see Ruapehu and Ngāruahui in the background. So in the North Island, we realised the midges seem to be doing quite well. So we set up some sites in 2003, and we had 12 sites, and we randomly assigned a release and control plots at each site. And then we measured the percentage cover of Hieracium between 2006 and 2012. So the midges obviously established well, but at half the sites, the densities were too low by 2012 to have an impact. They were still quite scarce, whereas at the other half of the sites, they'd done quite well, and they'd galled up to 33% of the plants, and the Hieracium cover actually reduced. And these regressions show how the percentage cover of Hieracium changed over time. So the control and low density midge plots are very similar. There's a decline there, whereas the high density midge plots, we saw quite a more pronounced decline in the cover. Excuse me. So in the plots with high density midges, we saw a 29% reduction in Hieracium cover. And in control plots, there was an 11% drop. So we attributed the 18% difference to midge damage. And it's also interesting to see that drop. We wondered why that might be the case. And we think it's the Kaimanawa wild horses, we're pretty sure the densities of those dropped over those years. We could see grass recovering and replacing Hieracium. So in the South Island, things were a little bit different. We actually were surprised in our recent field trip to find the wasps at just about every site we visited, especially in Canterbury. You could just get out of the vehicle at any point really and find galls, wasp galls, which was surprising. And the midges also were quite common. They'd established at most of the sites, but they were still quite restricted in their range. So some were only a few hundred metres away from release sites, and others, or there was one in particular that was about 15 kilometres from the release site. So almost the reverse in some ways to what happened in the North Island. So our sampling was different in the South Island too, because we mirrored past vegetation sampling that had been done by Lindsay, Smith and others. So we set out 40-metre transect tapes at locations that had been measured in the past. And at every metre, we put out a 20 by 20 centimetre quadrat, and we measured the Hieracium cover. We measured bare ground and rock. At some sites, there was quite a lot of rock and bare ground. Stolons, and we looked at the galling from wasps and midges and quantified that. So this is an example of one of our sites. So the tape was laid out and we measured the quadrats. And at this particular site, we had 60% cover of Hieracium, and this was our best wasp site. We had 87% of the stolons were galled. But the midges were only on less than 1% of plants. So we actually went through and we destructively sampled these small quadrats to make sure we were getting all the galls. So if we look at the attack levels in the South Island, on average, the wasps galled 67% of stolons, which was quite surprising. But the other thing that was quite surprising was that only 7% of the plants that we actually looked at had stolons. And the midges actually galled 10% of plants that we measured. So if we look at the impacts of combined, combine the results here, because quite often both agents were at release sites. They'd moved and infested the sites that were previously just had one agent. And there was actually no overall change in cover between 2005 and 2020. So this figure highlighted down here, this is 0.5%, so virtually zero. But if you look at the sites, and we do have a limited number of sites here because we didn't do the Marlborough sampling, at sites where there was no change in management, we actually saw a 7.6% increase in Hieracium. And at sites where we saw some management, so grazing was released or fertiliser was added, we actually saw a reduction in Hieracium. So we also measured lots of other sites where vegetation data were not available from 2005. So I've just plotted these data. So I've plotted proportion of galls and versus Hieracium cover, and put a linear regression in. And obviously the variance in the Hieracium cover is not explained by the proportion of plants galled. So something else is more important. Something else is actually determining Hieracium cover at this stage, not the presence of biocontrol agents. Although I'd have to add here that if you look at the proportion of plants galled, it's still fairly low. So if we can get a large proportion galled, this relationship may change. So the changes are probably due to land management in Canterbury and Otago, so irrigation, cultivation, reduced grazing pressure, fertiliser like lime and sulphur. And this theory is backed by anecdotal evidence from farmers in the Marlborough region. So it was quite fortunate in the way I found this, this article on Stuff about Hieracium. So it's 2018, so it's quite recent. And I'm just going to read a few quotes from this article. So the Aulacidea has just had 3 of the best years for growth. They have feed as they have never seen before. That's because they have had a good rainy autumn and spring and summer. The other grasses have managed to seed and get themselves going and outcompete the Hieracium. In country that's been developed and seed and fertiliser put on it, Hieracium is definitely on the decline. Another one, put fertiliser on or alter the pH with a bit of lime, and other plants around it get a chance to establish. And just 2 more. So in the tough areas with low rainfall like we have, where it is not worth doing a lot of oversowing and top dressing, it is not on the decline. And the Department of Conservation has done some work at the Tekapō Scientific Reserve, where they have taken away all the grazing for stock and rabbits, and natural plants are out competing the Hieracium in those plots. So there's a bit of a pattern there, which is consistent with what we found. So to conclude, while biocontrol agents have become common in some areas, population densities are still building and more time may be required to realise potential impacts. And the 18% reduction in Hieracium cover in the North Island was not seen in the South Island. And it is possible that Gaul midge is not doing as well in drier sites in the South Island. And that's certainly something we saw while visiting South Island sites. So Hieracium cover is still high in areas with unimproved pasture, and further biocontrol agents may be required in future to control Hieracium in unimproved pasture, where dry and exposed conditions may be limiting midge impacts, and seed feeders may need to be reconsidered as well. So that's my talk. I'd like to acknowledge a few people. Lindsay Smith, obviously, he has been working on this project since day dot. And I'd just like to personally take the chance to personally thank him for all the work he's done on this project and other projects. He's been a real trooper out in the field. And Gavin Loxton, you'd go a long way to find a more enthusiastic guy. Gavin helped me organise and visit a lot of these stations, which are some of them are well out of the way, and sometimes it takes half a day to visit one site. So Gavin was just invaluable in that respect. Barry Wills also helped with some sampling. The New Zealand Defence Force helped to fund the impact assessment on the midge in the North Island. And the Sustainable Food and Fibre Futures Fund has funded the recent checks that we've done in the North and South Islands. Thank you.
Excellent, Paul. Thank you very much for that. That's very cool. Really nice stuff to see what's going on out there post our releases. Paul has been, there's some questions coming in now. So the first one is from Robin Shea. How did you choose the specific insects to use for biocontrol?
This is a standard process whereby usually, well, sometimes people from Cabby do this for us. Sometimes we travel overseas and do it ourselves, but we go to the native range where these plants exist and we look at what's damaging the plants. And then we go through a process of prioritising them based on the damage they're doing and how host specific they are and what parts of the plant they damage. So for Hieracium, we went for insects that were feeding on the vegetative parts of the plant. We didn't think that the seed feeders were worth looking at, but that may be something we need to reconsider. So yeah, it's a fairly standard process we go through.
Excellent, thank you. Tony Robinson has asked, any idea why the other 3 biocontrol agents didn't establish? And also, wasn't there a rust also introduced?
The other 3 agents, thanks Hugh, the other 3 agents didn't establish probably because we didn't release enough of them, so we had problems rearing them in the lab. They were quite difficult to rear. And the rust is out there, but it wasn't introduced as a biocontrolled agent. We found it in New Zealand. It had got here by itself, and it's not that common. We didn't find it at many sites, and there has been some suggestion that we may need different rust strains to get better impacts on the the plants we have in New Zealand.
Cool, thank you. So Robin Shea again, is there any concern or known issues with native plants being targeted?
Can you repeat the question?
Oh, sorry, did I disappear on you? So
You
Robin Shea's asked again, is there any concern or known issues with native plants being targeted?
No, that's part of the process that's gone through. And if there is incidental damage, then there's a cost-benefit process that you go through to decide whether or not it's acceptable. But no, not for the Hieracium biocontrol agents.
Excellent. Linda Conning has asked, how many sites were on conservation land, do you know? And she's asked a second question, what are the conservation implications? Not quite sure what she means by that question, but how many sites were on conservation land?
There were no sites that we visited that were on conservation land. We were primarily focusing on stations and run holders. However, there are still measurements being taken by Gavin Loxton and co, and we'll include those data into the analysis a bit later on. In terms of the conservation benefits, I think the Tekapō site that I did mention from that article, it did show that if you release the grazing pressure, that you do get some recovery on native plants. So it might be a combination of land management and biocontrol in the long term. Even though we're not seeing spectacular impacts from biocontrol at this stage, sometimes these things take a long time. I've worked with heather beetle and it's taken over 20 years for that to really, get going. So I think that's probably about it.
All right, thanks, Paul. Shane Honer has also asked, I think he's got a couple of questions, but the first one is, the Gaul midge was released in frost flats in Upper Rangitikei River on the Napier-Taupo Highway. Have you ever checked this site?
No.
Cool, that was a quick answer. There you go, Shane, you got your answer just like that. He has asked a second one. I found the original release site in February, but couldn't find any sign of the biocontrol agent. So he's actually checked it himself. So basically a comment, but it's not one that you have checked. Okay.
Sometimes you do need to get your eye in a bit with these agents, but you do need to get down, on your hands and knees and look quite carefully. And some of the midge damage is quite subtle, especially if it's not that common.
Quite right. Okay. Shane should know what he's looking for, though. It's true. Dave Marks has also asked, it sounds like multiple tools are needed to address the challenge. Any thoughts about what the optimal mix would be, thinking about the combination of management approaches and introduced agents, and what level of reduction is ultimately realistic if we have a multiple group of approaches?
God, that's a really tricky question, and I think it really comes back to land use, and you need to decide in the long term what you want to do with the land. If you want to develop it, then Hieracium becomes a non-issue, it seems. If you're allowed to develop it, I guess the tenure review has caused issues for some farmers in that they, if they haven't accepted those offers, then they are restricted in what they can do on their land. And if they have bad Hieracium issues and they're not allowed to fertilise, then it's a very difficult issue, a very difficult problem for them. But certainly things like managing rabbits can help. If rabbits are involved, then they can encourage Hieracium growth, as far as I understand. Yeah, so it's a pretty complicated issue, I think.
Fair enough. Last question that we've got up here at the moment is from Fiona Thompson. Could an issue be that the gall just reduces clonal reproduction and spread, and the plants move to sexual reproduction to maintain populations when the galls are present?
Yeah, that's a good question. I think we need to, if we want to continue with this program, obviously it'll be, we have to prioritise other things, but if we want to continue with this, we need to understand a little bit more about the plant and how it and how much of it's vegetative and how much of it's through seed and recombination of genes. I'm not aware that we actually know all we need to know about that, so we may need to learn a bit more.
Cool. I guess I have one other question myself, Paul. I think you did mention something about other agents, but do you think there's it's worth considering revisiting the original agents that we released that failed to establish? Do you think it's worth revisiting those and trying to see if we could establish them a second time round?
I think that's not a bad approach. We already have permission to release them. We have some experience with rearing them. We might be able to come at it from a different angle. I'm not sure. I don't. Probably it's maybe Lindsay could answer that question a bit better. But yeah, that would be my approach to try and get those things going again. They were chosen because we thought they would do some damage and be good agents. So that hasn't changed. They're just a little bit difficult to rear. So it's a matter of funding and how much time you want to put into it, how much effort you wanted to put into it. And the other option too is to look at a seed feeding agent. There was a fly that was shortlisted but not introduced, and that could be another avenue as well. But like everything, it just comes down to the amount of effort you want to put into it.
Yeah, and I guess it also depends on just how much of a problem Hieracium still is in the New Zealand sort of agricultural systems or in conservation land as well, how big an issue it is in terms of reducing natives, but also reducing pasture production. You still see plenty of it when you look through the Mackenzie Basin and stuff, don't you, really?
Yes, it's a very good point, because with the tenure review, I guess farmers are carving off areas that are perhaps more productive. So for them, they can deal with the issue if they can manage the land. When Gavin and I were visiting high country farmers, a lot of them were more concerned with horehound, for instance. And so
really?
as time progresses, I guess problems change, and whether or not it's still the same issue it was in back in the 80s, I'm not quite sure, but certainly there are other weeds out there. Briar was another one that I was surprised with how far that had spread. Yeah, it's all about prioritization, I guess.
Yep, true. One of the things that does intrigue me about something like briar is I think we looked at that, but it was extremely difficult to find a biocontrol agent that didn't attack roses. So
that's the problem. Yeah.
Yep. Right, we've got a couple of other questions for you, Paul. I think these will probably be about the last two, but one from Mike Steenhauer. Are the growing number and range of wallabies in places like the Mackenzie high country a focus as yet? I don't really think that's a question for us to be able to answer, to be honest.
I certainly know there's effort put into shooting wallabies, but that's about the extent of my knowledge.
I'm sorry, Mike. I don't see. So I don't know whether he's suggesting whether wallabies have an impact on Hieracium or high country pasture production or whatever. I'm not sure. I have no ideas what impact wallabies have on.
Yeah, I think rabbits would probably be a bigger concern. You'd have to have quite a few wallabies, but again, yeah, that's I'm out of my depth.
Yep, me too. Last question from Dave Havel from Department of Conservation. Are there any results from overseas work on Hieracium biocontrol?
No, I'd have to get back to you on that one. I'm sorry, I haven't looked at that.
Has anyone else actually who else has got a problem with Hieracium that would have done a biocontrol program? I don't even know who it might be. Lindsay would probably know, but
yes.
he can write in and tell us. But I don't know of anybody else that actually has a biocontrol program overseas against Hieracium at all.
So. They've worked on Hieracium in the States. They've looked at reproductive systems and yeah.
Yeah, apparently, so Fernando Mackay tells us that Chile is, actually that would be true, Chile has worked on Hieracium as well, so I'm not sure who that would be. All right, well, I think that's it. Thank you very much, Paul, and thank you to everybody else for attending and enjoying this talk about Hieracium, and until we do it again later on today and tomorrow. So thank you very much.
Thanks, Hugh.